Welcome back, dear friends. In this lecture, we would be concentrating our attention on hybrid electric vehicles. So, the focus would be on hybrid electrical vehicle setup. We all know that hybrid electric vehicles they use both an electrical propulsion system as well as an internal combustion engine system. So there are various ways in which this two, that means the electrical propulsion system and engine can be set up to spin the wheels. These configurations can be summed up into four categories. So that is what we are going to discuss now. So what are those four electrical vehicle configurations of hybrid systems? They are series hybrid, parallel hybrid, series parallel hybrid, and complex hybrid. So we would be discussing one by one these configurations. The first we would be discussing is the series hybrid. Look at the figure over here. This configuration is the simplest configuration to make a hybrid electrical vehicle. The motor you see over here is connected to the wheels. The engine is used to run a generator. The engine is used to run a generator. The motor is connected to the wheels. And the engine which runs the generator provides the electrical power. It can be put as an electrical vehicle that is assisted by an engine generator. So from the figure, it is clear that this is assisted by an engine generator. The advantage of such a configuration is that it is an efficient configuration with an optimized power plant, an optimized drive line. It has a long lifetime. The response is pretty fast, and obviously the emissions are lower. The disadvantages is that you see the traction system, it is a large traction system. It requires proper algorithms, and you see that the conversion steps are multiple over here. So the arrangement is pretty simple. As you see, the schematic which is shown in front of you would convince you that this is the simplest of the hybrid electric vehicle. As you see the next configuration, you would be in a position to relate the two. Just have a fix at this configuration. Look at the configuration once again. You see that the engine is connected to the generator, and this provides the electrical power. This is a charger, okay? It's charger, battery, and a flywheel or a capacitor. So the engine is assisting this electrical motor, and this electrical motor is the one which drives this wheels. Okay, so just remember this configuration. Now we would move to the next configuration, which is a parallel hybrid configuration. So the parallel hybrid electrical vehicle is in front of you. So what do you see over here? You see that in this configuration, both the engine, the internal combustion engine, and the motor, the electrical motor, they are in parallel. They are in parallel to the wheels. Okay, look at the earlier configuration. These were in series. The engine and the motor were in series. Here you find that the motor and the engine, they are in parallel to the wheels. Either one of them can take part in delivering the power, or both together can take part in delivering the power. Okay, so motor can drive this, engine can drive this, or both of them can drive this. It can be considered as an IC engine vehicle with an electrical assistance. So one can look at it from this perspective, that it is an IC engine driven vehicle with the assistance from the electrical motor and a battery system. The energy storages in such a vehicle can be charged by the electrical motor by means of regenerative braking, or it can be charged by the engine itself when it produces excess power than what is required to drive the wheels. So it has got the same advantages as that of the series hybrid, that is, it is simple, okay, but it suffers from the limitations of a complex control, and one needs high voltage to ensure efficiency. So this is about the parallel hybrid. So just remember the configuration, and you must be now convinced that this configuration is pretty different from the earlier configuration, the series hybrid which we discussed. One can think of combining both the series and the parallel configuration. And if we do that, that becomes a combined system or a series parallel hybrid system. So what you see now in front of you is a series parallel hybrid system, hybrid vehicle configuration. In an effort to combine the advantages of series and parallel, these systems acquired an additional mechanical link compared to the series type, or an extra generator when compared to the parallel type. Okay, so you see that as compared to the series type, if you compare this configuration with the series type, what you find is that there is an additional mechanical link. Okay, and if you compare it with the parallel type, you would find that there is an extra generator. Okay, so it provides the advantages of both the systems, right? That is, it provides the advantages of series systems as well as parallel system. But obviously, when you are having this kind of configuration, then if you look at the configuration, it would be pretty clear that it would be a bit complicated and more costly. This drivetrain, you see that it is basically complicated because of the use of planetary gear unit. A less complex alternative to this system is to use a transmotor. In this system, the engine is attached to the stator and the rotor stays connected to the drivetrain wheel through the gears. The motor speed is the relative speed between the rotor and stator, and controlling it adjusts the engine speed for any particular vehicle speed. Okay, so this was about the combined hybrid electrical vehicle. As I said, this combined hybrid electrical vehicle is also known as series parallel hybrid, and it is an effort to combine the series and the parallel configuration. So just look at this arrangement. You see the engine, there is a drive line over here, there is a generator is connected to the charger, battery and a charger, they are connected to a converter, and there is a motor over here. And this, both this, that is the engine and the motor, they can be brought in series and also in parallel, okay, because of the complexity of this arrangement. And you can get the advantages of both the system to drive the wheels. The last configuration which I am to discuss today is a complex hybrid electric configuration. Complex hybrid system has one major difference as compared to the series type or a parallel type or a series parallel type. That means it has a difference that it allows bidirectional flow of power. It means if you had talked about a series hybrid or a parallel hybrid or even a series parallel hybrid, there was a unidirectional flow of power to a particular set of wheels. Here you find that there is a bidirectional flow of power. Look at this system. There's a rear wheel, there's a front wheel, there's a mechanical coupling over here, and there's a mechanical coupling over here. Okay, so the power could be bidirectional. It could be going to the rear wheel independently, it could be going to the front wheel also independently. Look at this system. It appears to be a bit complex, and that is the drawback of the system. But it has been adopted in certain vehicles. For example, Toyota Motor, they have adopted a constantly variable transmission system, and it is used to take this dual axle propulsion. Okay, so this system is found in Toyota CVT systems, and this CVTs, that is the constantly variable transmission systems, can be implemented hydraulically, mechanically, or electromechanically also. So you are basically splitting the power, and this complexity, that is you are splitting the power into either driving the front wheel or the drive wheel, is the reason why you are calling it as a complex hybrid electric vehicle. Especially four-wheel drive vehicles, can benefit from using two motor hybrid configuration, and that is what is seen over here, that this is a four-wheel drive and you are having two motor hybrid configuration, and you don't need a power transmission system to the back wheels. Okay, because the back wheels has its own motor, so you don't require a power transmission system to the back wheels, and this provides an advantage of energy reproduction by means of regenerative braking. Okay, so this complex hybrid electrical system is relatively new in the market, but this would also be this also needs to be considered because some vehicles, as I said, Toyota Motor has brought this configuration. So what we discussed in today's lecture was an overview of the different configurations which are possible with hybrid electrical vehicles. First, we discussed the simple hybrid system. Then we talked about the parallel hybrid system configuration. Then we talked about a combined series and parallel hybrid system. And finally, we discussed the complex hybrid electrical vehicle system. So that's for today. See you in the next lecture.